Okay, so hi everyone. I'll just say that this is the first time I ever talk in a conference, so super excited, and I hope you enjoy. Thank you. Yeah, so the name of this talk is Beyond Alembic and Django Migrations. My name is Noam, as Jacob said. I'm working as a software engineer at a company called Ariga. I like hiking, so I found this picture of me just last year walking into Italy. So here I am again. A bit about what we do at Ariga. So part of what our team does is to maintain two fairly large open source projects. So this is a lot of fun and a big pleasure. The first one is called Ent. So Ent is an entity framework for the Go programming language, so an ORM for Go. It was started by the founder of Ariga, Ariel, when he was working at Facebook. And it was then open sourced, and now it is part of the Linux Foundation. So the second project is called Atlas. Atlas is a tool that lets you manage your database schema as code. So it's a schema migration tool, and it's based on modern DevOps principles. Okay, so today's talk is about ORMs. If your app reads or writes from a database, then you might use one. ORMs, object relation mappers. This is the layer, this is the component of your software, of your application that maps between your Python classes and your database schemas, and your database specifically queries and statements. So its goal is to provide an abstraction for your database to let you interact with it in your Python code. And while there's a lot of stuff to discuss about regarding ORM, there's a lot of interesting discussions like how they work or whether you should use them in your application or not. Instead, I want to zoom in today into a much more specific topic in the world of ORMs, and that is the subject of schema migration tools. Sometimes they're also called schema management tools, specifically the ones that ship with the popular Python frameworks. So, just as a short recap, what we are talking about. So, what are these data migration tools, schema migration tools, sorry, and what are they used for? Basically, as my application evolves, my data model changes, then my database schema would have to follow along. Which means that if, for example, I have this user model in my Django application, and I want to add the birthday attribute to it, so I want to start tracking the birthdays of my users, before I ever execute or before I ever deploy this code into production, I would first have to somehow execute this command on the database, because otherwise the code will run, and it will start issuing queries, trying to read or maybe write from this column, and the database won't know what we're talking about. So, let's see how it looks like on a framework, the SQLAlchemy framework. So we have our models defined as Python classes. So here we have a class called user and a class called match. We're tracking the results of a game of some kind. And we also have the migration directory, which includes the instructions and the scripts for the database to upgrade it and to create tables and columns as we desire. Now, let's try to edit the schema. So we will add, look, no hands. We will add the points attributes to the match model. And we'll see the change. So we're adding points. We want to start tracking the score of each game. Changes look okay. We're going to keep it. And now, Copilot is telling us that we have to run this Alembic command. Basically what it does, it compares the state of our migration directory with the state of the schema and the code, and it produces a new generated migration for us. So, lo and behold, we can now execute it and upgrade the database to match our schema. So, everything until now is great. Overall, we can say it's a pretty great developer experience. Not only because Copilot is writing the code for me, but also because the Python community in general have really great frameworks, Django and SQLAlchemy. Each comes with its own abilities and its own schema management tool. And I don't need to understand how to define the models on my database. I don't need to know, I'm not a database expert, I don't need to plan the changes. I just need to state in Python code the way I want the schema to look like. And the tool that I'm using is doing all of the work, including generating the plan for updating the migration to the database to the next version. And this is overall a pretty great experience, like I said, and I think that if everything is great, maybe we can just stop now and we can go wait early. So what do you think? Okay, so of course I'm kidding, and what I really want to talk with you about today is the question of when you should, as a developer, consider an alternative. What are the scenarios in which you may want to be looking for a general purpose migration tool and eject from the default one provided by your framework? To explain this, I want to introduce a concept that in Ariga we often call the hidden bias of ORM native migration tools. And there are 2 points to that. So first of all, we are stepping into the shoes of an ORM maintainer for a minute. And I'll say that in order to provide a minimally useful product, I want my ORM to be useful, I have to ship it with some kind of schema management solution, right? If I'm only giving my users a way to interact with database schemas, but not a way to create and manage them on the database, then my ORM is basically useless. Ariel, like I said, who is the founder of Ariga, and he created the Ant ORM for Go, so he puts it really well. So what he says is that as an ORM maintainer, I see schema management as a necessary evil. I want to spend my time on the runtime API and performance optimization and not generating alter table statements. So what it means basically is that as an ORM maintainer, I want to focus on the differentiating factors of my ORM, making it better. I want my users to like my ORM. I'm going to focus on the factors that most people care about, which is the runtime API. I want to make a good developer experience in the runtime library. And I want to make my ORM fast. I want to make sure that it produces efficient queries. So thinking about the developer experience and the performance of the schema management solution is always going to be a secondary effort to me. It's always going to be lower on my priorities. And the second point is that, as we said, ORMs are supposed to be abstractions. The code that you run, that you write in them, is always supposed to run exactly the same, whether you're using SQLite or Postgres. And these are completely different databases. The way I'm going to achieve that is by only focusing on the lowest common denominator. I'm only going to provide you with the basic functionalities that any database supports. And if I don't do it, then my code won't be portable, and most ORM maintainers, they care about it. They want their ORM to be the ORM for a specific programming language. They're not going to break that abstraction. So what it means for us is that as developers, when we use an ORM, we are only getting the tip of the iceberg of what we could actually get from our database. Typically, we have tables and foreign keys and some basic indexes. But what we are not usually getting in most of the ORMs is stuff like functions and store procedures and triggers and views, etc. The list goes on. And a quick side note on that is that I know some people may be hearing me and they want to say, well, that's fine, right? Because I know about good architecture. I know that the database should be replaceable. It should be negligible. I don't want to couple the logic of my application with an external system. I want to use the repository pattern, so that's fine by me. But I can tell you, as someone who has been around as part of my job at Ariga, I'm talking to many development teams and many platform teams. I can tell you that a lot of teams really still do want to use all of these features, actually for good reasons. These pieces of software called databases, they are excellent in handling data efficiently. Some of them have been around for many decades. So there are plenty good reasons to use them. And just to name a few, we don't have time to go over the full course, but I can use, for example, functions and store procedures if I want to offload some of the heavy computation in my application to the database itself, where the data lives. I don't need to query the data, and then I can save some back and forth, serializing, deserializing the data back and forth from my backend and my database. I can use triggers, right? If I want to have some custom consistency rules of my schema, for example, I can express them in the form of code that will run every time the data is modified. And I get a guarantee from the database that it will stay consistent. So every trigger runs in the scope of one transaction, and I avoid any rest conditions if I do the validations in the application itself. Okay, I can use views, classic example. If I have, for example, a table that contains some sensitive information, I can use a view that only contains the non-sensitive parts, and then I can use the access control mechanisms of the database in order to make sure that only privileged users can get the table itself. In the same way, I can use materialized views. If I have some heavy queries, I don't want to compute them on the fly. I want to do it offline. And by doing it on the database itself, again, I can save some back and forth between the database and the backend. Extensions, if you are doing any kind of AI in 2025 and you're using Postgres, then you know about pgvector, also Postgres for handling geographical information, etc. And indexes. Okay, so as my application grows, my tables are becoming larger. And I may notice at some point that some of the queries are getting slow. And that is because they are not efficient enough. So one way to fix it is to improve the queries. Sometimes I can do it, but putting the right index can maybe greatly optimize my queries, the performance of my queries. Also, I've been in a talk before about partitions in Postgres, and someone asked, how do I use partitions in Django? So hope you'll get an answer soon, if you're here. Okay, what happened? Pause for a second. What happened if in our existing example from before, in our gaming application, we will try to add a materialized view, for example. Okay, so let's tell it, let's tell Copilot, please add a leaderboard materialized view, and we want to start tracking users, wins, and points. We want this leaderboard. It's a heavy query. We want to do it offline, and let's see what it says. So it's thinking, and it's telling us this. Okay, so basically, sorry. Okay. Never mind, basically what it told us is that the query, the materialized views are not supported in SQLAlchemy, so Alembic doesn't know about them. What it can do for us is to create a manual script, just basically the DDL definition. We can run it manually on the database to create the view, but we wouldn't, we can keep track of it for the future. Okay, so now we are responsible for we are manually responsible for managing the life cycle of this materialized view, all of its deployment. If it will change in the future, we don't get this magic that we saw before of automatically generated migrations for our view. So, if we want to use one of these advanced features, if we want to program on the database, if we want to still doing so while still keeping while still managing all of our schema with one tool that can do all of this magic of automatically generating migrations for us, then we need to be looking for a general purpose migration tool, one that doesn't have this bias that ORM native tools does. And this is a good time to present Atlas. Atlas is the main project that we are working on Ariga. Its core engine and its providers are open source, and it is used by many great companies in production against real databases, and it's sometimes called the Terraform for database migrations. Now, I will show a quick demo, and sorry for doing it with AI, also all the demos with just talking to Copilot, but it's 2025 and I forgot how to code. So, let's see. Same example as before, Atlas lets us manage our schema as Python code. Same classes, same SQLAlchemy models, and we also have the migration directory. This time it contains just SQL definition, just plain DDL for defining the models on the database. Now we can run the atlas migrate diff command. What it will do, it will compare the migration directory with our code, see if there are anything to update, and currently it says that they are synced, okay? Let's now try to edit the schema. So let's try to add a new attribute to the match. Let's call it hello, I don't know. And we can run now the atlas migrate diff command once again. What will happen this time is that Atlas will see the difference, it will pick up the change, it will compute a new migration for it and add it in our migration directory. So now we can deploy this new code to the database in production. Okay, so far so good. Now we want to see how we can maybe add a materialized view. Same as before, we're going to the chat and we're asking it to create a materialized view called leaderboard, and we want to track wins and points, and let's see what it does. Okay, so it's thinking and is looking at the configuration of the project. It's saying it's an Atlas project, and it sees that we are using a composite schema, which means that I can layer additional SQL definitions on top of my Python code. So that goes into this schema-as-code file. So we will go there and update the code there, just adding the migration directory in the SQL file. And now, if we run the atlas migrate diff command once again, then Atlas will combine the definitions from the plain SQL and from the ORM definition and produce one schema from it, and then it will derive a migration. So now we can apply it to the database so we are happy. But we also want to make sure that the materialized view is working, right? So we will write a test. So let's go and generate a new test for the materialized view. And Atlas also comes with its own testing framework. So I can write simple tests, as we will see in a minute. And basically just a simple test defined in a format called HCL. And just something really minimal, we're inserting some data into the view and querying it to see that we are getting what we expected. And we run in the test with Atlas schema test, and we see that it passes. Okay. Okay, so summarizing what we just saw. So using Atlas, you can still define your data model with Python code, same Python code as before. Atlas can load the existing definitions into the schema and manage them same as Alembic. Additionally, you can also layer extra SQL objects. You can utilize any database features that you want in SQL. And the diffing tool takes all of this into account and produces one schema. Plus, we also saw a demonstration of one of Atlas Pro features. There are many things and cool things to show and talk about, but there is a testing framework that can let you write tests, so you can make sure from now on that the schema is doing what it is supposed to do. Okay, this is all good so far, but as we know, in 2025, the job of a developer is not only writing code. Building application does not end with generating migrations. With the rise of modern CI/CD in the past decade or so, we know that the job of a developer has been extended to also thinking about how we deploy, how we deliver our app. So, just as a short recap, when I'm talking about CI, I mean everything that I can do to make sure that stuff doesn't break before I deploy it. So that may include maybe tests, or maybe my security team is requiring me to run some kind of security scanner on my code to make sure that it doesn't have any vulnerabilities. What about schema migrations? Okay. When I'm talking about CD, I mean that we want to make sure that we can deploy without human intervention whenever we want. Okay, so I don't want to connect to a server with SSH and upload files to deploy. I want my deployments to be automatic. I want them to be workflow based. I want to be able to control who deploys, etc. So there are a lot of modern tools for that. Now, migrations are a risky business, and you probably know it if you ever dealt with schema changes, schema migrations in production. There are a lot of things that can go wrong. There are a lot of ways where we can shoot ourselves in the foot. Just to name a few, we can have destructive changes. Okay, maybe my migration is dropping some tables or some column. If I do so, then the data inside of this table is now gone forever. I can undo the migration if I want to recreate the table from scratch, but without the data, okay? I know that it maybe sound a bit trivial to talk about, but just last year, a company called Resend, they provide an email API. They had a major incident with downtime, and from the incident report that they published, we can see that this is exactly what happened to them. They had a migration, the migration dropped some tables, and the tables were crucial to the operation of the system. In their case, they had a backup, but still not a place you want to be in. I can have what we call data-dependent changes. So in the form, for example, of constraint violations. If I have a migration that adds a new constraint on the data, maybe it will pass on my local development database because it doesn't have any data that violates the constraint, but in production it will fail. And what happens when a migration fails midways, depending on how things are set up, I may need some manual intervention to reverse things or to fix the issue, and again, not something that I want to find myself doing. I can have breaking changes, so obviously if I'm breaking the contract between the database and its clients, so for example, if I rename a column, then it may also break stuff unless I know what I'm doing. And yeah, table locks, so that topic is a bit more advanced. Basically some schema changes. In order to perform it, to fulfill them, the database will have to lock some resources. For example, classic example for this, in MySQL, if I am editing an enum column, I want to add a new value to the enum. I'm not adding it in the correct place, and there's a subtle difference. Then MySQL may need to rewrite the entire table. If it's a large table, then this rewrite may take a lot of time. And during that time, there is an exclusive lock on the table. It's basically down. So what do we do about all of these risks? So Atlas was created with the understanding that not every developer is a database expert, but we still want to develop fast. We still want to have short iterations. So this is why we can use the Atlas migrate lint command. It's basically just a tool which is like a linter for migrations. I can run it on my migration directory, and it scans the migration and warns me about potential hazards. Here you can see that it's warning me about adding a unique index, which is a data-dependent change, and also having an operation that may require a lock from the database. So far so good. What would be even better is if we can run it also in CI. So this is why Atlas also comes with its own GitHub Actions, also integration with GitLab and Bitbucket and all of the major platforms. Basically just automatic code review on my migrations. Every time a new migration is created, it analyzes the migration and add comments. Here, for example, you can see that it's warning me about destructive changes. So if I want my PR to be approved, I need to either ignore it or handle it in some other way. So this is for CI. And now let's talk a bit about CD. So one of our observations is that regarding deployments, ORMs are not concerned with how you deploy. They don't have an opinion on how you get the database schema to match the code, how you deploy your migrations. Basically, if your team probably has any kind of deployment pipeline, you will have to figure out yourself how to insert this phase of deploying the database schema into your existing pipeline. If you're using Kubernetes, then you have to write the integration yourself. If you're using Atlas, then there are plenty of existing integrations. For example, you can use the Kubernetes operator of Atlas, so basically just making your database schema another resource in your cluster. If you are using Terraform, then you can make your schema just another part of your infrastructure. There's an Atlas provider for Terraform. Also, if you're deploying with GitHub Actions, there are actions for that. Also, once again, for GitLab, for Bitbucket, etc. Okay. Last point on when you should consider using Atlas instead of the default tool provided by your framework. So if you are in a team that writes a service that it's a polyglot, meaning you have multiple services and they are written in different languages, different frameworks, you have different database you want to deploy to, and you want to have one standard way to manage your database schemas, instead of using for each framework its own machinery, then Atlas, the same way we saw Atlas working with SQLAlchemy, we can also do the same thing. There are providers for all of the major ORMs in the popular languages. Okay, so wrapping up, we started by asking what are the scenarios in which you may consider using Atlas in your application. Then, first of all, maybe you shouldn't, because like we said, the Python community has really excellent frameworks with great toolings. If you're not looking for anything fancy, then that just might be enough for you. But if you want to use any of the advanced database features in your application to enhance your application, and you still want them to be these objects to be part of your schema that you manage with your tool, and also if you want to build a robust CI/CD pipeline, and you don't want to start reinventing the wheel and build in your own integrations. Also, if you are building a service that it's a polyglot, that includes maybe many languages and many different frameworks, you want one standard way to manage your schemas, then you might be, Atlas may be just a good fit for you. Okay, finished a bit early. Thank you for listening.
Thank you so much, Noam.
Thank you.
We have quite a few questions.
Oh, wow.
So how do you handle, you can handle migrations in a micro-framework architecture where tables are actually shared between different microservices? There is something that Atlas can help in this scenario?
Yeah, so it was my last point, actually. The same way, you can actually define your schema the same. If you choose to define your schema in the way of in the form of one ORM that you're using, maybe the main application or the first application that was reading from this service. Then you can do it with an ORM, but otherwise there are a lot of different ways and data sources and forms to declare the state of your schema. So yeah, you can use the same. You can maybe extend the schema with different sources, like we saw in the demo. Yeah.
And how do you handle large migrations that block table or have migrate data? Can Atlas help with this large database operations to mitigate the down?
Data migrations are not technically supported yet. It's on the roadmap. About large operations, for example, one example that we are facing in Italia is we use a multi-tenant architecture, which means we have to redeploy the same migration directory once over and over to new databases. Which means that basically we add a lot of migrations, and the more the migration directory grows, then the operation is becoming slower and slower and slower because there are a lot of statements to execute. So one cool feature that we use from Atlas is a checkpoint. You can create a checkpoint migration. It just squashes all of the changes that you had so far, and then it runs much faster.
Thank you. And there are quite a few questions about the future support for NoSQL databases to help migrating the document schema.
For NoSQL databases?
Sorry?
For NoSQL databases?
NoSQL databases.
Okay, so I can tell you that we are currently working on some new drivers. I'm inviting you also to join the community on Discord, and we are getting requests, and we are basically just responding to what we see that most of the users want. Currently, there isn't any planning to support a NoSQL database, but if there will be demand for it, then.
Yeah, there was another question, exactly how to help expand the supported database, and you just answered that.
Okay.
And sorry. Do you plan to, or do you already support migration merging like Django does, like consolidating multiple migrations in a single one to, I don't know, when you're creating new databases based on the existing one, instead of having a lot of different migrations, just consolidating in a single large migration?
If I understand the question, this is basically the composite schema that I demonstrated. Mm-hmm. You can actually define, we saw it in the demo. You can basically define a composite schema. I hope I understand the question correctly. But basically, you can define just a list of sources for Atlas to get the schema definitions from, and it will just manage them as one schema.
Okay. And if you need further clarification, you can talk to him later.
I'll stick around. Also, by the way, I have some swag. If that's appealing to anyone, then.
And how the testing of the migrations works? I mean.
Testing?
Yeah, the testing.
Yeah. Okay, so I also demonstrated it, but basically there's a nice format. You can define your tests in an HCL format, and you can put all your tests in one directory. And basically, you run the Atlas schema test or Atlas migrate test. Okay, there's a subtle difference depending on your needs, but basically these tests are a really nice structure. You do a setup. Okay, so for example, you can insert data into your database. And then Atlas make sure to apply it, for example, the latest version to the database you are testing on. And then the setup runs, and then there are assertions, and at the end, Atlas does a teardown, so just cleaning the database up. So. Yeah.
And does Atlas detect possible risks, when migrating between different databases, like migrating from MySQL to Postgres? Does Atlas support this?
No, so it's a schema. No, it's a schema migration tool, meaning it's there to migrate your database from one version to the next. Data migrations and transfer between databases. It's not in the scope.
Okay. And there are talks about Django ORM and migrating primary keys. And
I'm sorry again.
Django ORM and migrating primary keys. I mean, probably the change between int and big int or something like this, I suppose.
So what's the question?
And how Atlas supports such large changes?
Large changes on the
Huge
Django?
changes, I mean, probably in terms of long-term, long-lasting changes. Let me know if you write the question, and let me know if I have not explained it correctly, and you can explain yourself.
Actually, I think I understand the question. I don't have a response on the top of my mind, so maybe.
But feel free to
maybe you
to
can
catch Noam later. Thank you so much. Lunch break is starting any minute, and session will.
Thank you.